Hey everybody, welcome back to the Level Up podcast where we talk to some of the brightest engineering and DevOps leaders about what it takes to build great products, teams, and companies. I'm your host, Ken Rose, co-founder and CTO at observable. Today I'm here with Tamir Dresher, head of architecture at Payoneer. Payoneer is a global payments platform for digital commerce. They started in Israel in 2005 and went public last year in 2021. Tamir is also the author of RX.net in Action and a prominent member of Israel's Microsoft developers community. He's also an instructor at the Rupin Academic Center teaching software engineering. Tamir, thank you so much for joining us.
Thank you, Ken. It's great to be here and meet you.
Yeah, so I was wondering maybe we can start our conversation a little bit about just talking about reactive programming in general. Like you literally wrote the book on RX.net, but I was wondering if you could talk to our listeners a little bit about just what is this idea behind reactive programming?
Yeah, sure. So when we say reactive, we actually we have two definitions for that, at least from my side. There's the reactiveness inside an application, how the application itself is written in what we call the reactive paradigm. And there's this concept of reactive systems, how we build systems to be reactive, which is based on this what is called the reactive manifesto. So in an essence, when we say that something is reactive, what we are trying to say is that this component or the system knows how to react to things that happens in a way that makes it easy to scale, make it easy really to overcome all kind of fault, making it resilient, and basically be responsive to what happened. So this is true to both what I said about reactive programming itself and also as a system, but the way we achieve it, the implementation itself is different, and also kind of the guidelines on how we achieve that. So let's start maybe talking about an application which is reactive, and we'll start by talking about how we wrote code which is not really reactive. And so applications really needs to react to all kind of things that happen, right? The user writes something inside a text box or clicking a button, or maybe it's listening to some kind of a sensor or whatever. And now the question is how you really perform the action based on that. In the old days, you can say, when we have this type of events, we wrote some code that knows how to attach to this specific trigger, and then you have a piece of code that is running. And so if you had those multiple triggers coming in, then you have this code spread inside your applications. And when you wanted these things to really work together, somehow synchronizing those type of reactions, then the code became really, really bloated and spread all around the application. And what the reactive programming itself came to do is really to create these primitives that really allows you to define these type of sources in the reactive extensions, what we call those observables, and work with that in a way that allows you to create a chain of operations, operators on top of that, really creating a pipeline on what needs to be done when this type of event or this type of really trigger happened inside the application, in a way that can propagate those changes all along this pipeline in a way that is really, really easy to capture the essence of what you're trying to do without really dealing with how it is being done inside, making the code much more maintainable and easy to read. So this is about reactive applications. When we're talking about reactive systems, again, we want the system itself to be responsive, we want it to be resilient, we want it to be elastic, and the way to achieve that is really by accepting this concept of asynchronous processing by message driven architecture. And again, building the application in a way that knows how to react to that. And we have various tools today to do that, whether it's working with queues, or working with data streams such as Kafka and others, and working maybe with the actor model in this entire system that knows how to be scalable and really really to contain this type of concurrency inside.
Amazing. So there's these sort of two levels. There's reactive at sort of like the individual application level, like your app is reactive or the service is reactive. And there's the reactive architecture, which is that like you have these foundational infrastructure pieces that allow for this sort of asynchronous processing to occur.
Exactly.
Awesome. I want to dive in a little bit on that first part, right? The reactive applications, this kind of reactive framework. You mentioned observables, and you talked about, RX gives you these primitives. What are those actual primitives? Like, how do you start to like assemble, a reactive application together?
Oh, that's a great question. So really, what reactive extension helps us to do is really to look at everything as a stream. Okay, everything is a stream in the reactive world, and this stream is something that is being represented by this primitive called observable. Now, the observable really is representing this source of data, events, or something else that happen, and this can be like a simple variable in your code, like a simple integer that holds values. When we are talking about an integer in a really in a simple programming language, it has a static value and a time. You can change that value, right? But the things that depend on this value won't know that it has changed. Now with observable really emits changes every time something changes. On the other side, we need to really react to those changes and do something with that. And the thing that knows how to listen to that is the observer. And the observer is another primitive that we have, which knows how to attach to the observable. And so, taking again this example of a variable, I might be an observer that wants to perform an operation of summing two numbers, right? Both of them are variables inside my code. In a really in a simple procedural code, you will have your result, the thing that does this summation, really take the two variables and sum them together, and you have this value. If any of those changes, nothing else will happen with the result. Now, with observables, each one of those variables will be an observable, emitting the changes of the value, and I can have really an observer that is attached to both of them, right? Every time any of those changes, the really the result is being recalculated, and then again, because we can look at this observer again as being an observable, the result itself will be emitted. And so if anything else in my system, in my application, needs to know about this change, again, it will subscribe to those changes. Now, only with those two simple concepts, we can really build really an entire framework. And this is really what reactive extension is providing us. We can have a lot of operators that knows how to combine those values in different type of logics. We can now introduce the concept of time and maybe batching those changes for a specific time duration, only reacting to the last one happening in a specific time frame. And so now we can build this type of pipeline of what I need to do based on those changes, really in a way that is similar to how we write a SQL, right? When we
Right.
say what we want to get in a result without really implementing how the database itself is going to do it, and
Right.
just
Just declarative over imperative kind of model.
exactly. So we have these observables, we have those observers. They define really as an interface the contract, how they communicate between the two, and in between we can insert more and more operators. And some of those elements can be both. They can be both an observable and an observer. We call this a subject. And when an observer is subscribing to a specific observable, we have the subscription itself, which is something we can now dispose or we can cancel when we don't need to listen to the events anymore. And this is more or less the basic fundamentals of how we achieve this reactiveness inside applications.
Awesome. So it's really like I'm remembering, back to my like third year concurrency course, like producer consumer architecture. There's like there's the observable, and then there's the observers that are always listening for messages, and then there's this extra bit on top that allows for easily querying and giving. It sounds like a lot of just the usual like functional programming type of
Exactly.
utility things, like projection and querying and filtering and being able to like slice and dice the data as an observer that you need to get.
Exactly. So yes, a lot of it, we got a lot of inspiration from the functional programming paradigm. Only that now we have another layer that knows how to really look at the changes as the first class citizens of what is happening inside, allowing us as developers to really, in a declarative way, define what we want to happen and not, messing around with all the concurrency and how we need to
Yeah.
synchronize between things.
The relationship or the kind of analog you gave of like SQL and declarative versus imperative. I remember this was 20 years ago now, like writing really shitty imperative code that was like it was basically waiting for two different responses from two different sockets, and it was like, okay, you have all this logic of like, okay, if the first result comes, you do this, but if the other result comes, you have to do this. And you have all this state basically you have to manage yourself to be able to keep track of like which comes in first and what buffer are you filling and then how do you combine. And it sounds like RX just takes that away. Is that a fair comparison? Like this is why RX is better compared to like the old way of just synchronously programming and doing yourself?
Yeah, for those use cases that really reactive extension is solving, it's a great solution. I would also, it's worth mentioning that it really depends on languages. Some of the languages don't really provide the utilities to easily work with concurrency, multi-threading, and so on. And so reactive extension really shines in those places. Um, I mean, it's kind of recently we have inside JavaScript all kind of we can say primitives to really work with this concurrency, async await and stuff like that. Before that, you didn't really have a way to do it nicely. You always kind of resorted to these callback chains, callback hell, and so reactive extension make it much more easier for you to work with that. In other languages, which have a lot more of tools for developers to inside the code to work with concurrency and multi-threading, you see other type of patterns emerge. And so the nice thing I think that you can see in reactive extension is that you have a way to move between this kind of old way of doing stuff, enumerating things, and converting it into the push model where you are not really, interactively going over something like iterating on a collection or something like that. Instead, you write your code as something that from the outside, the value is being pushed and your code just react to that. And we can see it inside C Sharp, we can see it in Java, in other languages as well. And so does, it makes it easy for developers to choose the right tool for the right job because there is a way to move from one way to another in the same piece of code.
Right. Yeah. You can, if you want to use the old way, because that is better built or the better solution, you can. But if you want to, not worry about the whole for loop, but just kind of the body of the loop and just one element at a time, you can adopt RX.
Exactly.
You kind of touched on this. I had this other question about like, so my mental model is there's observers, there's observables. Those observables have to run somewhere. There has to be some, I don't know what I'll call this, execution context. There has to be some scheduling that occurs. You talked about like in JavaScript, like before async and await. Can you talk a little bit about like, where do those actually run? Like, does RX as a system manage the scheduling for you? Do you just kind of throw a thread pool at it? Or what's the actual underlying execution model?
Okay, great question. So another primitive inside reactive extension is called the scheduler. Okay, and so um, reactive extension by itself doesn't really decide for you where something is going to run. It is up to you as a developer to decide. And so again, we can even look at a specific, a really simple collection of items inside our code, like a simple list, as something that will be an observable. Now, obviously, when I'm going to subscribe as an observer to this collection, something in the background is just going to iterate on this collection and emit. And so we can specify when we do this kind of subscription, we can specify if we want the execution of really what the observer is going to do, if we wanted to do it on another thread, if we want to just dispatch it on the same synchronization context we are in some implementation of RX, you can even kind of inject a scheduler that will kind of move the work that is being done to another machine another cluster that does some of the work for you. So it's up to you to do that. What we have inside Reactive Extension is really the abstraction that allows us to really perform that, the scheduling of a specific execution, or maybe a timer that will allow us to also scheduling to the future. And on also really, I think one of the really the thing that Reactive Extension made very well is abstracting time. Because once we have this scheduler, we and the scheduler itself can again schedule things for a specific time, we can play with that and say for testing, for example, that we are controlling this scheduler and really moving it back and forth in time, really to make sure that our pipeline is going to really do the work it needs to be done without really waiting for this period of time to move on. And so we have those type of implementation. One notable implementation that is worth looking into is what is called Reactor with a K, with a Q. Okay.
Okay.
And so this come and take this all reactiveness paradigm into this level of we have multiple machines that needs to run, and some of the code is being done here, some in another place, making it really, really interesting concept to look at.
But it sounds like the abstraction is still there, that you're allowing for that kind of coordination and synchronization, even though it doesn't matter that it's one machine with multiple threads or multiple machines, all doing work. There's still some idea of coordination behind all that.
Yes, of course. I do think it's important to note that one of the things that is in a way lacking inside Reactive Extension is really how we deal with backpressure. The observer itself is going to receive this type of notification or events or data that is being pushed into. And so what happens if the rate of events is really, really too high for what this observer can really work with? I mean, it's like drinking from a hose. Okay, so we don't have a good answer inside Reactive Extension how we can somehow tell this observable wherever it is. I mean, if it's coming from another machine, coming from a queue, or just inside my application, you know what? Wait, don't
Right.
keep pushing things because I can't handle it.
Yeah, I'm having analogs to like how TCP works, where there is a channel for back pressure to allow for things to slow. It sounds like the model with observers and observables is that it's just one way, right? That there is no kind of second channel that allows the the observers, yeah, to signal like please stop and just start queuing work.
Yeah, exactly. Or at least not in the standard implementation. There are variation of the implementation that try to really provide it, but it's not something that became like the standard of how we do it.
So I'd love to shift gears a little bit to understand, you're at Payoneer. Can you talk maybe a little bit about some of the challenges of just nothing about Payoneer specifically, just the challenges of having a fintech and scale, and maybe, some of the ways that reactive programming can help with some of those challenges.
Yeah, sure. So really, so Payoneer provide kind of a platform or infrastructure for cross-border payments, trying to overcome some of the challenges we have with the traditional way of moving money between countries. And so, as you can imagine, we allow our customers, and um, we have many type of customers, right? We have those merchants, we have like small or medium businesses, we have partners. They try to feed our system with payments that they want to move into another customer that use our platform. And so the scale is one of the challenges we need to deal with, right? Because as a customer, when you do this type of action, you want to receive, the response in a timely manner. But what happens when you give us the instruction to do that? There's a lot of, phases until we can really say, okay, we need to make sure you have the money. We need to make sure that the other side can receive this money. There's a lot of regulations in this area of finance, okay? And us as a fintech company, we are regulated, we have licenses. And so really, when you as a source really of the payment reside in a specific territory, but the one that needs to accept the money is in another territory. We need to make sure that we are under the regulation. We can do that. We can, dealing with money. We need to make sure that the level of risk is okay. That there's no fraud. There's no money laundering. So a lot of things need to happen. And so how you do that in scale, and now you can react to those changes that are coming, both from the customer side and also from internally in our company, because regulation change, there's a lot of things happening. The geopolitics changes. Sometimes there's a war, and so we need to know how to deal with that because some sanctions might happen. So those are a challenge for an organization, but architecturally, these are big challenges. How can you do this type of rules that are going to be, triggered by all
Dynamic.
kinds of
Yeah.
things, and make sure you can provide the service in a good level for our customers and everybody around. Okay, so those are the type of challenges. And so going back to reactive, and we didn't really talk about this, we didn't go too deep on reactive systems, right? But this is really the core of being a reactive system, being able to, scale, being able to be fault tolerant, because bad things can happen. It can happen because, something technical happened, or because something else. We know as customers that sometime it might happen that we see that we were built for something, but we didn't really get this product or service that we paid for, and so we want to withdraw really this payment back, right? So the payment is not necessarily just moving the money that you ask for the other side. It's also moving it back, canceling this type of transactions. If you asked us to move the money to your banking account, right? And there's a problem in the bank itself. Maybe you closed your account even before we managed to put the money. We need to know how to handle that. So being able to scale elastically, being able to work with those type of problems, being resilient to them. We are a distributed system. So in the world of distributed systems, things tend to fail. You need to know how to overcome it. Those are a lot of the challenges we need to work with. And so one of the things that help systems to be reactive is really, again, leaning on this asynchronous processing, being message driven, knowing how to work in a messaging way, or event driven way, even if you as a customer see it as a synchronous operation, right? So this is another type of challenge, but this is really the way to scale a system.
That's amazing. I was wondering if you could give us a sense of the scale in terms of like how many customers or how many queries per second, like how many transactions, like what's the overall kind of volume that Payoneer is processing?
Yeah, so Payoneer is really Payoneer has millions of users all around the world, and really I think the problem is not just having millions of users, and again there are kind of distributed in different type of users, and each one has its own type of services. You can also the based on the amount of transaction you make, you will have more services on our platform, or maybe you as a user want specific services that we can allow you. So doing that and also doing it all around the world, like 200 countries, don't get me for the exact number, so millions of users, 200 countries, each one with a different regulation, tens of financial institutes that we know how to work with, and financial sources and targets for money. This is a scale. Amount of transaction, it really it changes a lot. As you know, like Black Friday is soon,
Yeah.
right? So amount of transaction is a big amount of transactions per day. Okay, I wouldn't go for the second or the minute here, but a vast, really a big number of transactions that we need to process. Each of those transaction is really kind of a snowflake. The type of conditions and checking we need to do for each one, the amount of money, the source and the target that might change. All of this create a really big complexity for a system. So I don't know if it answers your question, but maybe you can derive this type of scale that we need to work with.
I can imagine 200 countries, tens of banks, millions of customers, and yeah, the seasonality of it with things like Black Friday. Let me ask you this, I guess, one thing before starting at Ops Level, I worked at Shopify, and Black Friday, Cyber Monday had a lot of preparedness that went into it, because generally the traffic there would be three, four times what the usual kind of baseline was. That was sort of year after year the standard. I don't know if it's the same at Payoneer, but can you talk about how you've seen the reactive applications and reactive architecture be able to handle kind of that increase? Like the goal of reactivity is like, yes, you have this elasticity. Have you kind of seen it bear fruit? Have you seen it play out that way?
So first, it's a challenge, and I must say that you don't really know in advance really what is the correct way to do things, and so we are learning all the time. One of the things that really helps doing that is to have a solid monitoring and SRE, really people that knows how to, provide us this, kind of a bubble maybe of protection for all kind of things. And so um, sometimes you start small because this is the right thing to do at a specific time. And as you grow, you re-architect that into something more mature architecturally. You learn along the way all kind of things. When I talked about messaging, so first, how do you distribute those messages? How do you make it in a way that you won't have like a really hot spots for specific, just how you partition the data is another type of challenge. And so you can say each one of those partition will handle, let's say, I don't know, 100 customers. But inside this pool of customers for partition, you might have one or two customers that are really massive. Okay, having those two together can break this specific partition. Okay, so this is a challenge. How does the system, because again, the system is not just one component calling a second component. It's sometimes a chain of components. Okay. So again, how do you know when you find inside deep inside this chain that something happened? How do you propagate those type of errors back? How do you handle maybe the repeatness? Because you as a customer, let's say you're a partner working with our API. Okay, you did a call and something crashed on your side. So you come up again and then you do the second call. You retry it. So we need to protect you. We need to know not to, make the
Remove the
payment
funds
twice.
twice. So yeah,
Right.
exactly. Yeah.
And so while we're at it, something can happen from the other side. Maybe something in the banking system really told us that this payment cannot be done. Okay. So protecting those kinds of things and synchronizing. The way to do it is really to base your architecture on this principle of reactive systems, really on making the correct messaging of the system, and knowing how to write the code in a way that is idempotent. Okay, and so trying not to do this concept of distributed locks, moving away from that into things more like sagas, making the workflow itself distributed. So this is the type of things that you need to see how you really how you can move this logic of your system into this type of architecture. And it's a challenge because it's a cultural change, it's a technological change, and really doing changes in a system like Payoneer is really equivalent of replacing a tire in a car, right, in a racing car, while it's still, inside the race. And so, how you do those kind of things in a zero downtime, at least mindset, okay? These are all challenges we need to overcome. And so, I don't have like a single answer on how to do it. We, you know, establish some guidelines inside and we try to follow them. But really, you need everybody to be on board. You need to have high quality members in your team, professionals. And yes, we are learning all the time.
Nice. How would you recommend, let's say that for one of our listeners, they're in an organization, they're listening to this podcast and say, oh, I want a reactive in my organization, right? Like I think that they have all the same challenges, they're dealing with different inputs that can change at different times, and they feel the reactive architecture is going to help. What's the best way for organizations to sort of start adopting reactivity? Is it better to start from the bottoms up with like start with one application and change it to be reactive code? Or should you start from the top down, start building reactive, layering in new reactive parts at the system level?
So I think that building the system in a reactive way is not really the same as building a specific application in a reactive paradigm, reactive extension. I do recommend for teams to look at reactive extensions and see how they can really improve their coding by using that, especially for the front end kind of applications or the front tier of the applications. So this is something I will allow a team to look at and really decide how to work with it. And some teams are doing it already because it became, such a standard way to do certain things. I mean, people working with React and Redux kind of have this type of mindset already established, and just they need to take it maybe to one level extra. Doing a reactive system is something that first I will encourage people to read the Reactive Manifesto and watch this. Today we have a lot of material on the web. There's like the Reactive conference every year where people are sharing. So I will advise to look and try to get from the knowledge of others to start doing that. And then starting small with a specific area inside your application, specific domain, taking one of those services and try to do those changes to fit into the reactive paradigm inside. Again, there are many ways of doing that. I also mentioned like the actor model. Depending on your language, you can have different type of implementations for that. But this is another way that really take this concept of reactiveness into the to another level. So I will encourage people to look at it, and I think by just thinking of the problem in this type of way, they can really eliminate a lot of the challenges they already have today with creating a consensus between different partitions or workers, and how to distribute work and distribute it on the cluster and so on. So those things are kind of coming free. So look at those type of implementation and then try to take from that the lessons on how you can feed it into your applications.
Amazing. Tamir, before we wrap up, I always like to ask our guests, what's your favorite music to work to when you need deep focus?
Wow. That's a good question. So it's kind of, it depends on the season. So I like psychedelic trance music when I'm in that kind of mood, okay? Or I'm moving to the more soft, quiet rock. So it really depends. I have this type of seasonality, like you mentioned, in how I work. So sometimes I'm more energetic. So yes, the trance music is something that helps me do this kind of work, faster. Other times I need to relax and focus, so I will go to the more soft rock.
Awesome.
Yeah.
And Tamir, what's the best way for people to follow you on social media?
So I think the best way is contact me on Twitter. So Tamir _Dresher is my Twitter handle. We will share it, I guess. So I think that's the best way. And also inside LinkedIn.
Awesome. Well, everyone, yeah, absolutely. We're going to be putting the links for your Twitter and LinkedIn in the show description below. So everyone, feel free to follow Tamir on those channels. So yeah, we today talked about all things reactive. We talked about reactive code, reactive systems, how to architect reactive applications, and some of the challenges of building a fintech company and how reactive can help solve some of those. Tamir, thank you again so much for joining us today.
Thank you, Ken. Thank you for inviting me.
And thank you again to all of our listeners. If you have any topics or guests you'd like to see on the show, please send us an email at levelup@opslevel.com, and we'll see everybody next time. Happy building.